Thank you so much for the introduction. Good morning, everyone. Respected chair, co-chair, my fellow panelists, ladies and gentlemen in the audience. So I'm today going to talk a little bit about our experience with demand response in India. But before I do that, I think we are, as you mentioned, we started a little late, so we've got to maybe reduce the presentation time. So it's a form of a demand response that you see that we have to maybe change the pattern of what we give out. Very briefly, a little bit of marketing about ICF. And, ICF has been around for some time. We started in the US in 1969. Today, we are present in a number of countries. We have about 55 offices globally, more than 5,000 people, listed at NASDAQ and $1 billion in turnover. The only business we have is consulting. And we work with a diverse set of clients. A lot of our business is with governments, regulators, funding entities, developers, financiers, and it's across a number of countries and a number of sectors. We are present in energy, environment, and transportation in a big way. About 1,500 people work in energy business alone across different geographies. We do a lot of work in health, environment, health, education, and social sectors, and also work in the digital transformation area of business. So what I'm really going to cover today, I'll just briefly talk about what demand response is, although I'm sure we are all familiar what demand response is, but just to set a background about what really demand response is and how the use or the context of it all is changing, and more particularly with the rapid changes that we are seeing with variable renewable energy and new technologies like storage coming of age, electric vehicles expected to come literally like a storm. So how DR's role has also changed with all these different changes, and how it can complement a quick or a rapid response literally by the distribution sector to these new developments. I'll talk a little bit about the international experiences in DR, and then spend more time on experiences in India where some pilots have been done. ICF has carried out a couple of pilots, one in the state of Rajasthan with the utility of, with the Jaipur Discom, and one in New Delhi, which we recently concluded maybe a couple of months ago, where some pilots were carried out. So I'll maybe share what our learnings were out of these pilots. So, before moving on, sorry, I missed one slide. I think it's an important slide. What is really demand response? And here I would just actually like to read from what has been mentioned by FERC. I think what it importantly mentions, demand response is really about changing the electrical usage by the resources which are at the demand side from the normal consumption pattern. And this change could be in response to either prices in the market or incentives that are offered to consumers. But it is most needed when there is need for system reliability by the system operator, or even at the time when there are markets where the demand aggregators can go and sell these services and get some money from energy arbitrage. So coming to the context in India, what is the benefit of demand response for a discom in India, and what is the benefit for the consumer in India? If you look at the discom, I think the benefits are well articulated and understood globally. The Indian discoms are also waking up to it. Obviously, it provides a tool to balance the demand and supplies at times when there is peak demand and the supply is less. But equally, it can also provide a response when the supply is high and the demand is low, if we talk about a demand up response rather than just a demand down response. And this links back to the actual definition, which says it's changes in demand, and these changes could be a reduction in demand or even an increased demand, where consumers can be incentivized to maybe shift their demand from non-peak to actual time when there is a generation peak, so that you're able to integrate renewable and don't have the curtailment problem. It can obviously help in managing any emergency situations for discoms. But more importantly, I think what we've tried to do through the two pilots in India, we've tried to assess the benefits for the consumers and also tried to explain these benefits to the consumers. And some of the benefits that kind of have been understood is that it helps discoms provide uninterrupted supply, which in case of India is quite a critical issue where there are long power cuts. If during peak time the discom is able to reduce the demand, it helps them avoid these blackouts. It also helps a discom in keeping the overall tariffs down. And I think this is something which has not been well understood so far. But if you look at in the context of the discom, if the discom is supposed to provide 24/7 power in the event when it starts doing that, it will have to make further investments in terms of infrastructure needed to support the peak supplies. At that time, if demand response is available as a tool, the discom can actually reduce some peak demand and therefore avoid some investments, peaking investments, and thereby keeping the tariffs low. So again, very briefly, what a demand response is. If you begin really from the right side of this graph, you see the utility and it has certain needs. It has certain peaking demand and it has certain supply sources that it has negotiated. And on the left are your DR participants or the consumers who are essentially going to participate and give the response. And in between, matching these two could either be a demand aggregator, which interacts with all the consumers and provide a service to the utility, or even the utility could do it itself. Some of the kind of demand response that we've seen are either manual demand response or automatic demand response. Manual demand response is when the utility will actually either call or through some ways message the consumer to reduce their demand, for example, and the consumer in response will reduce their demand and confirm that they will reduce. Automatic DR is a step forward, and it is where the most of the world has moved, where the utility has automatic control on certain controllable cooling devices or lighting devices at the premises of the consumer, and can actually on its own either reduce or increase the load within the limits and bands that have been agreed with the consumer earlier. Just to show how it helps, and this is again, if you see the graph here, what you see is the red line is the baseline, and this is for every hour, the 24 hours of the day. The red line is really the baseline where the demand would have been, but in between it shows that a demand response event was called from 11:15 in the morning to 2:15 p.m. and it led to a certain load reduction. So this reduction in load really is the response which is provided. This is just a schematic to just describe the context. And I'll move quickly to the next real cases where we'll show you how the actual demand response for some of the consumers came in. Before I move on to the India experience, very briefly, internationally, demand response is very well accepted, assimilated, and part of markets and normal operations of DISCOM. To the extent that in the US, there are utilities which are designing residential demand response programs, and these are also automated residential demand response programs. The current size in US is about 29 gigawatt for demand response out of a total which is almost 40 to 45% of the total control programs that they run. And demand response is estimated to provide somewhere close to 10% of peak shaving in the markets in the US. In Europe, it's slightly less, but still significant. Anywhere between maybe 6 to 8 or 10% peak clipping has been observed and achieved in Europe through DR. Some of the countries in Europe are actually much more advanced than some of the others in integrating this. But what we see is all the utilities are realizing the importance and the benefits of having this demand response and are clearly moving towards integrating it. This picture just shows a kind of a smart house. It's a representative smart house which has various devices which are kind of directly controlled by electricity management system. And that electricity management system interfaces with the DISCOM. And with the help of that electricity management system, the load can be varied automatically within set tolerance levels and set bands. And what you see in yellow at the bottom is the kind of a display that you would see in terms of what is the price for electricity at that point, and therefore what is the time for a likely demand response event. Now, moving on to the core of the session, really, which is our experience with the pilots that have been implemented in India. I've mentioned some of the pilots that have been implemented here, not all of them, and I do know that USAID is also doing some work on demand response in some of the projects. A couple of the projects were actually done by Tata Power, which Mr. Sinha would be very well aware. These were automated DR events carried out in Mumbai as well as in New Delhi. ICF has worked on two pilot projects on demand response. One has been in Rajasthan with the Jaipur Discom, and one recently concluded with BSES. And we were supported by Shakti Sustainable Energy Foundation for both these projects. So how we planned these two events out, there were 4 stages really, starting from the planning stage to the post-DR. And I apologize if the text is small, but you have the presentations, but I really don't want to read the text, but I think just to give you an idea, the planning stage is very important because you've got to select the customer, the right customers who you think will give you the response. You have to educate the customers about the benefits of demand response and also educate them how they can actually provide this demand response. As an example, if we go into a mall, they ask us, how do you think we could provide a demand response? And we probably tell them, if you have non-peak hours, why don't you switch off? If you have 2 lifts in the lobby, just turn off 1 lift and operate only 1 lift. So things like that, trying to help them understand on how they can provide demand response, all goes into planning stage. Then there is a pre-DR event where the information is sent by the utility to the consumers, and the consumers confirm their commitment to reduce the demand. And very critically, during the DR event, the system is monitored by the utility real time to see the impact of DR on their overall system and the congestion at that point or the demand and supply at that point. And then the other important stage is post-DR, when you're going to do the settlement, because as we said, there is going to be some incentive which is going to be paid to the consumers for the amount of demand response. So how do you decide how much demand was reduced and therefore the incentive that has to be paid? Moving on to the pilots that we did first in Jaipur. We started in Jaipur in 2014. We did the first pilot where we first of all did a trial event. What you see in the graph, this was done in the evening, 7 to 8 p.m. And in Jaipur, the primary consumers were industrial consumers. And the trial event ran for an hour. Each of the 4 bars that you see are the 15-minute blocks. We were expecting a 25, or we had tried for a 25 megawatt kind of a response, and we reached there, which was quite good. The first 15 minutes we had about 16 megawatt, but in the last 15 minutes the demand response reached 24 megawatts. What you see, the red line is really what is called as the baseline, which is where the demand would have been without demand response, and the black line is the demand as the response was provided. Then the first event which happened in Jaipur again in April 2015 was in the evening time. The event was identified by our RDPPC, and they were overdrawing power from the grid, and the frequency was also below 49.8 hertz for consecutive 2 blocks, and therefore they were entering into a stage where they had to pay penalties, and the penalties, as you know, under DSM are quite severe. So the benefit for Discom is that they are able to reduce their penalties if they are able to get a demand response, and this was an event which showed that low frequency is the right to how do you identify the right period for doing the demand response? You look at the grid frequency, you look at the time, and you project your load at that time, and then you anticipate the demand response you need or the reduction in load you need. Similarly, the next event happened at 5 to 6 p.m. Again, we received about 24 megawatt of demand response. I'm not going to go into too much details into each event, but just to give you a summary, these are the 4 events that happened in Jaipur. And there were 10 participants who had been enrolled earlier, who were provided some incentive per kilowatt hour of the demand they reduced. And overall, we received a demand response always beyond 20 megawatt, which was a very positive sign. If 10 industries could provide a 20 megawatt demand response for 1 hour, the promise it showed for engaging a larger set of consumers was tremendous. Coming on to, I don't know how am I doing on time, but coming on to Delhi and what our results have been in Delhi. We recently concluded demand response with the BSCS Yamuna Power Limited. We conducted 8 pilots with them over the summers in Delhi, and one of them was actually during the day, which was the peak temperature or the hottest day that was recorded in New Delhi recently, if you would have read. Before we actually identified which were the hours or time that they needed to demand response, we analyzed last 1 year's data that they had. We looked at the kind of the demand that they had and the deviation that was evident. So if you see these graphs, they're for 3 months, and the blue bars actually show their draw from the system, which is on the left in megawatt, but the red line really shows their deviation, and there were times when the deviation was as high as 150 megawatt from what the schedule that they had given. So which is a large deviation, and therefore they entered into those DSM charges and the penalties that had to be paid. On the basis of this, we kind of designed the DR program, and then 8 pilots were carried out, which are summarized over here. So it started in April 2017, and the last 8th pilot was done in 6th of June 2017. And by the way, maybe I forgot to mention, before we actually carried out these pilots, we also approached DERC with the concept and got an approval from DERC. We filed a petition, got an approval to do the pilot, and this entire pilot was supposed to show the savings. It was not an ask for any investment in any infrastructure or any incentives to be paid to the consumers. The idea was to show that this is going to lead to savings, and that was recognized by DRC that this DR could actually have a potential for savings, and they approved the pilots. So overall, the response we got was about 17.4 megawatt across these events. Each event had 1 megawatt to about 2 megawatt. Now you'd say this is much smaller compared to Jaipur, which is true. But the difference here is that in Jaipur there were large industries, whereas in Delhi, and I'll tell you in the next slide, these were all commercial consumers. So we had hotels, we had malls, we had hospitals, even office complexes who participated. So this just shows the kind of consumers we had and the response we had. So we had hotels provide the maximum response, and I'll tell you how many hotels were there as well. We had malls, we had DJB and railways also participate, which were drawing from BYPL area. And when we say manufacturing, it really is not manufacturing, it's the dairies, it's Mother Dairy, which was drawing the power. And we had office complexes and hospitals provide this overall response. The spread that it shows is the different DR events and the different times. We carried out DR event during the afternoon, during the evening, and during late at night, with a view to test the response of different consumers at these different times, and also therefore see what DISCOM could learn from these pilot events. So what we and this shows the results by each type of consumer. So for example, what this chart says here, when it says DJB on the left and 2 is a circle, it means that there were 2 DJB consumers who reduced their load, and they have a typical pumping load, water pumping load. So it's not really a demand reduction. What happened is that instead of pumping at 4 to 5 p.m., they said, okay, we can pump from 3 to 4 p.m. or 5 to 6 p.m. So they shifted the load. Okay, I see the time, but maybe another slide. Similarly, we had the hotels, 5 hotels participated, and the largest demand response was provided from them. And we had malls and the railways. This was recently covered in the press, but I'm not going to spend too much time here. So it got a lot of traction. I'll come to the last slide, and really last slide is what were the lessons that we learned from these 2 events. I think the first most important lesson that we learned was that although it's a new concept, but consumers picked it up very, very quickly, and they understood the benefits they could have, and benefits not just in terms of maybe a incentive we paid to them. We paid 1 rupee per kilowatt hour of demand reduced, but also they understood their load better. They were able to analyze and understand how do they actually shift demand, and if they want to benefit from time of day tariffs. DISCOM, on the other hand, and this was also a revelation, BYPL and their systems department really saw this as a very powerful tool where they could actually reduce the demand when needed, and they are very keen to expand it and expand the scale. We had 20 consumers enrolled. They want to increase it to 100 consumers immediately. What we also saw in case of Delhi was that there was a wider participation from different consumer categories actually helped, because different consumer categories had different kinds of loads and different abilities to shift the load. So an understanding of the consumer type with the kind of load they could reduce. And finally, we all realize that in our learning that therefore DR is a very powerful tool which can actually be a market-based instruments and not just to manage peak load demand and supply, but also when variable renewable energy comes into the grid and there is a need for a demand up response, demand response can actually allow or make that happen with the renewables curtailment actually getting reduced. With that, I'd like to finish and thank you so much. I'm sorry I'm a little over time.
Thank you, Gurpreet. Excellent presentation. And I think demand response as a concept has really caught on. Internationally, it has been done, and in the country also, the pilot projects have demonstrated the benefits, especially to the consumer, whereby they can switch off some of the loads, especially non-critical loads during peak hours, and get certain financial incentive. And the biggest, of course, the benefit is to the utilities, because what you can do is you can plan your load based on the control of the load that is being used by the consumer. So you don't have to typically tie up a huge quantity of power just to meet your peaking requirement. Your peaking requirement can be met locally, and that's a much better way of addressing your load rather than tying up power in very large quantity for peak hours, which actually comes for very, very short period in the whole year. In fact, based on some analysis, we found that in Delhi, the peak hours, the top 10 peak hours, or the top 10 peak load, 10% of peak load is only for about 50 to 60 hours. So from 8,760 hours, it's not even 1%, it's 0.5%. So just for that 0.5% period in a year, you end up with a huge quantity. What we thought that it may be a good idea if we can have the question answers at this stage. And if anyone has any question for Gurpreet, you can ask right away.
Demand side, you should have the total enrollment of the customer. And in India, when you look at from the Indian perspective, and you have shown the slide which says about the automation of the house, which is, I don't know how it is going to happen. But when you focus at the industry side, even there are a lot of resistance. So what do you think, how it can be implemented? Because the benefits are beyond doubts, they are good. But in Indian context, whether it is really going to work?
Yeah, I think that's an excellent question. I would certainly say that, household automation and demand response is still some time away in India. We need to have all the, smart meters and smart, although we are getting there, you're getting Wi-Fi enabled ACs. If you can control your AC with the Wi-Fi, why can't, a Discom utility do it? So you can actually bypass a lot of the investments that other countries have required. If you have all the, Internet of Things and all your devices are controlled through Internet, maybe you don't even need the wiring and the smart controllers. You just need a smart software. But still, it is a little bit far away when it comes to households. But for industries and for commercial establishments, and I think this was something we saw in those pilots. I think there is an initial resistance, but when we met each and every consumer before doing the pilot, and when we explained to them how this can benefit them, and they actually, and it does benefit them. It's just not on paper, that you have to reduce the demand. But when they realized the benefits that they had, and there was an incentive being offered, so ultimately in real world you have to offer some incentive. So we offered a 1 rupee per kilowatt hour of incentive for reducing their demand, and that incentive actually made them reduce their demand. And it's not actually a reduction, it's a shift. It can easily be done. For example, if it's a room like this, which is Taj Vivanta is running temperature of 23 degrees, if they want to give a response for 1 hour, they can actually reduce the temperature 1 hour before and then switch off the ACs for 1 hour and then switch it on again. So it is quite possible, across different type of consumers. You just need to educate them about their consumption patterns.
Yeah, I have a series of questions on that, but we can discuss maybe later.
Sure.
We can discuss offline. But let me supplement to what Gurpreet has mentioned. We have also done it in Delhi. And the solution as such, once you go and explain to the consumers, there is a lot of buy-in because they also feel, because of the time of the day metering for them, that they can reduce their energy bills. Secondly, that's a way of conserving energy for them also. So I think it's just that you need to make that sort of an effort to go and do the advocacy and educate them and tell them. As far as the home automation is there, again, some good solutions are expected. We have been looking at that very closely with some of the vendors and some of the companies who are into home automation, and simple solutions to control your equipments in the house are in the making, and maybe in next 1 year time, this will get populated. So this is a concept, it is a great concept, and I think it will catch on once there is more buy-in from the consumers. Yeah, sure.
I'm Preeti Malhotra from Ensign Global Solutions. Have you had, during these pilots that you did, any interactions with the regulatory authorities? What was the response, and what do you think is the way forward in terms of involving them?
Yeah, I think that's again an excellent question, because when it comes to DISCOM, the regulators is going to be involved in all of these things. As I had mentioned, for the Delhi, when we did the pilot, before doing the pilot, we actually went to DERC with a detailed petition which highlighted the benefits, and we got an approval from them. So the regulator was actually quite happy to support this pilot. But there is always challenge if there is investment involved. We did the pilot without making any investment and saying that it's going to lead to savings and therefore possibly even to a lower tariffs.
Can I ask a question, Mr. Sinha?
Yeah, sure.
I'm Anas Soda, Executive Director retired from Power Grid. In fact, Gurpreet made a good presentation, but my question would be to Mr. Sinha. See, you are handling Delhi distribution for quite a long time, and the Delhi's peak is in the summers, and it is, I think, beyond 6,000 megawatt these days. You have tried a lot, and a lot of smart meters have been put. You have the SCADA DMS also installed in your control area. My question is that what is holding you for starting the demand response in your area? Is it the regulators, or is there any other issue, technical issue?
We actually did the demand response 3 years back. So since then, we have been working on demand response. I have right now nearly 200 of our consumers with a connected load of about 250 megawatt. And the results have been very good, and we continue doing that. Now, initially when we were doing this, we did not have the regulatory approval. So people were doing it gratis, and no financial incentive was being given. It's only about a year back that we have got the regulatory approval, which Gurpreet was mentioning that when he went with the petition. So we actually gave the first petition and got it cleared, and then now all the other utilities have been given that benefit. So, so the Regulatory Commission has also approved and has understood that in the long term, this is going to have a huge impact. In fact, based on the initial results, it looks like 5% of our peak we will be able to meet through demand response, both during daytime and nighttime, which combined with the rooftop solar has a great potential to meet the summer peak in Delhi. So it will happen. It's a matter of time that more and more people get involved in this, and especially the rollout of smart metering that is taking place will help us in meeting the requirement of demand response.